Hello there, my fourth grade friends. Today we are doing Unit 4, Lesson number 2, which is on page 139 and 141 of your math book. So go ahead and grab that, and let's get started. So in today's lesson and video, we're talking about just like reviewing some concepts that we did in this book in second grade, which was what the equal sign means, what the does not equal sign means, how equations can be true depending on which symbol you're using. We're also talking about our math mountains here. We got our total, we got our addends, our sum, S-U-M, and then sometimes these are called partners. And then all the different equations you can write based on this relationship that you have here. We're also going to be talking about having a situation equation which matches the way a word problem is set up, and then how you can use an inverse operation, which is like the opposite operation, to set up an equation called the solution equation, which will give you your missing number all by itself on one side of the equal sign so that you can find the answer to your problem. So, and then we have a little puzzle penguin too. All right, so let's get started. Here we go. Discuss the equal and not equal sign. An equation is made up of two equal quantities or expressions. An equal sign is used to show that two sides of the equal sign are equal. So 5 can be 3 plus 2. 3 plus 2 can be 5, right? Is equal to 5. They're the same. 5 is equal to 5. 3 plus 2 is equal to 2 plus 3. 7 minus 2, which we know is 5, is equal to 1 plus 1 plus 3. All of these things are just different. You can sort of think of it as like that playground equipment called the teeter-totter or the seesaw, and it's balanced. Or it's almost like a scale, you know, one of those scales where you put paper clips and weights on one side. It has to be even. So if in this next case, you can see there's some situations where it's not even, so then you use the is not equal sign. So the is not equal to sign, which looks like a crossed out equal sign, shows that two quantities are not equal. So 4 is not equal to 3 plus 2. 5 is not equal to 3 minus 1. 5 is not equal to 4. 3 minus 2 is not equal to 1 plus 3. And 3 plus 2 is not equal to 1 plus 1 plus 2 because this side adds up to 4 and this side adds up to 5, right? And we know 5 is not. So these are just a couple examples. There are infinite, you know, but just to help you understand what I mean. So an equation can have one or more numbers or letters on each side of the equal sign. A sum or a difference can be written on either side of the equal sign. The sum is the answer when you're adding. So like that would be the sum here. And a difference is the answer when you're subtracting, how far numbers are apart from each other. So I'm going to write 2 examples, and then I want you to write 2 examples over here. Okay, so I'm going to say 10 times 10 equals 100. True. And then I'll say 1 plus 5 equals 6 equals 3 times 2. So this side is equal to 6, that side is equal to 6. This side is equal to 100, that side is 100. So balanced. Now you go ahead and write 2 that you can come up with. Okay? When you're ready, I'm going to continue. Now we're going to use the not equal sign to write 4 is not equal to statements. So you can have, you know, things on both the left and the right side. So I'm going to say 1 million. That is 1 million. 1 million plus 4 is not equal to 7. Right? And then what about 48 divided by 6 is not equal to 99 minus 5. What is 48 divided by 6? 8, right? What is 99 minus 5? 94. It's not the same. That's all that means, right? So you write your 2 examples right there. Now, we're going to move on to this section here, and we're going to choose the correct symbol to make this statement true. So here we have 5 plus 2 plus 6. And I know 5 plus 2 is what? 7, right? So 7 plus 6. Is that equal to 6 plus 7? Yes, it is. It's the same thing. Flipped. 80 is it equal to or not equal to 60 minus 20? Well, what's 60 minus 20? 40. Is that the same as 80? No, it's not. Not equal to. 70 is what compared to 40 plus 30? Well, it's 40 plus 30. It's 70. Is 70 the same as 70? For sure. Absolutely it is. This one, 18 take away 4, that's 14, plus 11, that is 25. Is that equal to 3? Nope, it's different. 50. Okay, now this is 55 minus 15. 55 minus 15 is going to be, what, 40? So that's not equal to 50? I'm doing these kind of straight. I guess it's supposed to be more like this. Sideways slash, but it's not a big deal. All right, 21 plus 6. What's that? 27. Minus 3. What's that? 24. And this side, 26 minus 4. 22 plus 2. 24. 24 to 24? Yep, those are equal. Right? All right, moving along. So, now we're talking about these inverse operations, also called opposite operations. So that's plus and minus, those are inverse, and then another set of inverse operations is multiplying and dividing. Basically, they just undo one another, right? So when you add, you put two groups together. When you subtract, you find an unknown addend or take away one group from another. Addition and subtraction are inverse operations. They undo each other. Addends are numbers that are added to make a sum, which is like the answer, right, when you're adding. You can find two addends for a sum by breaking apart the number. A break-apart drawing, we call this a math mountain in 2nd grade and in 3rd grade, can help you find all 8 related addition and subtraction equations for two addends. So which equations here show the commutative property? That's the one where you're having two things added, but it doesn't matter the order that they're added. So that would be like these ones here. So like 72 plus 9 equals 81, and 9 plus 70 equals 81. Also, these ones over here, 81 equals 72 plus 9, and 81 equals 9 plus 72. That's having those two addends or partners, you know, in whatever order, because it's addition, it's fine. What is the total in each equation? Where is the total in a subtraction equation? Now, this is something that can get kids tricked up a little bit. So the total is always the thing at the top. It's always what you get when you have the two partners together, right? So when you're subtracting, when you're adding, the total is going to be by itself. When you're subtracting, the total is going to be before you have the minus sign, basically. So 81, and then for the minus sign. Okay. Now what we're going to do is we're going to solve for each of these equations. So 50 equals 30 plus p. So what we're doing here is we have this math mountain in our minds. We have to ask ourselves, okay, how do I find this missing partner? What we do there is we do 50 take away 30. What is 50 take away 30? 20, right? So that means this missing number has to be 20. Right, so here. Same thing here. We have a missing partner. We know our total is 60. We know that one of the partners is 20. To find that missing partner, we have to do 60 take away 20. And that will be 40. And then right here, we know our total here is 90. We know one of our partners here is 50. And we know the other partner is missing. So what we can do to find that missing partner is 90 take away 50. And that will give us 4. So in each of these, all of these could be considered situation equations. And then when we finally do something to get, like for this one, we do 90 minus 50 equals that v. Getting that v by itself helps us find the answer. So that is the solution equation. Okay. Number 14. So write the 8 related addition and subtraction equations for the break apart drawing. So here, we're going to follow this model. We're going to do a total, and then the partners, or the add-ins. Total equals the add-ins. And then one of the partners, total minus the other partner. One of the partners, the total minus the other partner. All with one thing on the left side of the equal sign. And then we're just going to swap it for the other side. They're all very similar equations. They almost look the same. That's why we're going to follow this pattern so it's not like confusing. Okay? So our total here, 56. And then we'll do 48 plus 8. So 56 equals 48 plus 8. Then we're going to keep following this pattern, 56. And now the only thing we're going to change is the order of those partners. So we're going to do 8 plus 48. Then we're going to do the first partner. So 48 is equal to our total, which is 56, minus the other partner, which was 8. Then we're going to do the last partner, 8, and that's our total, 56, minus 48. Okay? Now we're going to do the same thing, except we're going to put the this single number on the other side of the equal sign. So you can go ahead and put all your equal signs over here. That. And then we're going to just do this first expression, this 48 plus 8. And what does that equal? 6. Then we're going to do 8 plus 48. And what does that equal? 56. And then we're going to do 56, this expression here, minus 8, and that is 48. And then we'll have that last one, 56 minus 48 equals 8. So they're all really similar, but it's important that you know the only thing we're not doing is adding anything to the total. Because once you say, okay, 48 plus 56, is that going to be 8? No, it's going to be like around 100, right? So just keep that in mind. You can add the partners together. You can take stuff away from the total, but you're not adding anything to the total. Okay, here we go. Write equations to solve problems. This is where we're going into that situation and solution equations. A situation equation shows the structure of the information in a problem. A solution equation shows the operation that can be used to solve the problem. So solution and solve, they're like very related words, right? So we need an equation to solve the problem. Draw a model if you need to. In a collection of 2,152 coins, 628 coins are pennies. How many coins are not pennies? So this is saying, so 2,152 is the penny amount, 628, and the non-penny amount, n. So then how do we find that n? We're going to have to, that's the situation equation, right? That's just saying it in the same way as the problem. Now to find that n, we're going to write the opposite, right? One of these that we can get that n by itself. So then we're going to have to do 2,152 minus that partner, 628, to get that n. And let's go ahead and do that over here. 2,152 minus 628 2 minus 8 is not gonna work, so you have to ungroup it. Then it's 12 minus 8, which is 4. 4 minus 2, which is 2. 1 minus 6 won't work either, so now we have 11 minus 6, which is 5. So then n equals 1,524 coins. Okay. Number 16. Susanna took $3,050 out of her bank account. Now she has $11,605 left in the account. How much money was in the account to start? So this is saying she had her starting amount and she removed the $3,050 and she was left with $11,605. How do we get what that S is? Well, we're going to have to add these two together. So we'll have the S equals 3,050 plus 11,605. So then we're going to set that up over here. 350 and then 11,605. 600, 4,000, 10,000. So S is going to equal 14,655. Try this next one on your own before I do it, okay? In the month of May, Movieland rented 563 action movies and 452 comedy movies. How many action movies and comedy movies in all did Movieland rent in May? So this one, that's actually kind of the same equation, right? So you're going to have your 563 action movies and your 452 comedy movies to get, M for movies. And then to find that, you're just going to add them up, right? It's already by itself, so it's kind of helpful in that way. 563 plus 452, 5, 11, 10. So M equals 1,015 movies. Okay. Now, we're just going to continue, I think, with this. Draw a model if you need to. The workers at a factory made 3,250 pink balloons in the morning. There were 5,975 pink balloons at the factory at the end of the day. How many pink balloons did the factory workers make in the afternoon? Give it a shot. Try it. Okay, so we have our morning, and then we have our mystery afternoon, and all together it made that 5,000 amount, right? So we're going to have our 3,250 plus P for pink balloons, and that's going to equal 5,975. How do we get that P by itself? We do our 5,975 minus our starting amount, 3,250, equals P. So let's go ahead and do that. 5,975 minus 350. 5 minus 0 is 5. 7 minus 5 is 2. 9 minus 7 and 5. 3. Hey, no ungrouping in that one. So P equals 2,725 balloons. We're just focusing on getting that missing number all by itself. Give these ones a shot. See if you can do it on your own. When you're ready, hit play. Terrence is planning a 760-mile trip. He travels 323 miles the first 2 days. How many miles does Terrence have left to travel on his trip? So he has this total of 760, and he's removing the ones he's already done. So 323, and that is m for miles, and that's the same equation that we need really. So we'll go ahead and we'll write 760 minus 323. 0 minus 3 is not going to work, so we got to ungroup. That's 10, so 7, 3, 4. M equals 437 miles. Okay. Give this one a shot too. There were some people, ooh, mystery number, at the football stadium early last Sunday, and then 5,427 more people arrived. Then there were 79,852 people at the stadium. How many people arrived early? So we're going to put P plus 5,427. So that's the early people and the later people. And then you have your total of 79,852. How do you get that P by itself? Well, you can take your total and subtract this other partner. So 10,852 minus 5,427, and that'll equal P. So let's do it. 79,852 minus 5,427. 2 minus 7 is not gonna work, so we have to ungroup. Now it's 12 minus 7, which is 5. 4 minus 2 is 2. 8 minus 4 is 4. 9 minus 5 is 4. And 7 minus nothing is 7. So P is going to equal 74,425 people that arrived early. Okay. Here we go. We got a puzzle penguin. Remember, the point of these is to help you identify common mistakes. So this might be a mistake that you might make, but maybe not. Okay. Dear math students, the problem shown below was part of my homework assignment. Mrs. Nason had a collection of 1,845 stamps. She bought some more stamps. Now she has 2,270 stamps. How many stamps did Miss Nason buy? To solve the problem, I wrote this equation. S minus 1,845 equals 2,270. I solved the equation and wrote that S equals 4,115. My teacher says my answer is not correct. Can you help me understand what I did wrong and explain how to find the correct answer? Your friend, Puzzle Penguin. Think about it. Pause and try to see if you can help this penguin out. You ready? Okay, so here's what he did. She had a collection already of the 1,800, and then she bought some more. Then both of those together made that 2,270. So basically it's like this is the math mountain. The total is 2,270. S is what she bought, and then she already had the 1,845. So to find this S, we don't need to add these together and get that bigger number. We need to take 2,270 and subtract the ones she bought to find what she started with. Or backwards. We need to take this total, subtract what she started with, and we'll find the number that she bought. So we say, whoops. You added when you needed to subtract from the sum slash total. I'll say sum in parentheses. Okay. So then we'll do, yeah, so the equation should be that 2,270 minus 1,800 equals S. All right, my friends. Go ahead and finish writing that down, and then when you're all done, see if you have an assignment, and I'll catch you next time. Thanks for joining me. Bye-bye.